The problem that we are trying to solve is how to effectively deliver food to communities isolated by natural disasters. The first steps in solving any problem is to define it and identify the objectives, functions, and constraints that will determine what solutions are feasible. The problem statement we created was, our group will solve the problem of getting food and supplies to communities isolated by natural disasters by designing a delivery system. We determined our two functions to be that the egg must not break and that the egg must finish within the landing zone. The constraints of the problem are that the design must launch from within a cubic meter, cannot exceed 4 joules of stored energy, must be deployed by a single movement smaller than 30 millimeters while using less than 5 joules of force, and that we must not spend over $25 creating our solution. Then, we identified what our objectives were to keep costs low and achieve high accuracy and reusability. During our ideation phase, we came up with various design alternatives. However, we narrowed it down to the 4 most feasible designs. The first option was a crossbow catapult, with an arm, sling pouch, and a winch. Then, a sliding crane with a low friction surface and a hammock. The third was a ramp with an accelerator, wheel tracks, and a padded cart. And finally, a spring launcher, which consists of a spring, guided tube, and platforms. With the various alternatives, we were able to select the most feasible design using a weighted decision matrix. Originally, the final design was to be a ball launcher, with the highest reusability and lowest economic damage. However, we had to consider the amount of force and energy needed to be able to launch the egg, so we went with the second highest rated option, the spring launcher. With our final design set in play, we began our construction of the spring launcher using the majority of the Fab Lab materials. For our base plate, supports, and height adjuster, we used a 1/4-inch Baltic birch plywood. A 3-inch diameter PVC pipe was without any question our best option, as it gave us enough space to be able to enclose the egg and still limit any energy loss due to its smooth surface. We are only capable of compressing the spring to one distance to be within the energy limit. This gave us the idea to have the design be capable of adjusting its height so we can be able to have more control in where we want the egg to land. The height adjuster consists of a hinge screwed into the base and a piece of plywood that will rest on the exterior of the PVC pipe. A dowel and plate mechanism were used to compress the springs. This was done by having someone grab each side of the dowel sticking out of the PVC, compress the springs, and place the zip tie on the screw sticking out from the bottom of the launch tube. The only thing required to launch the egg was to cut the zip tie so the compressed springs will exert energy onto the enclosed egg and launch it. We conducted a series of tests to ensure that our design would meet our requirements that we set out to achieve. These tests included a height test to ensure we were setting the launcher to the desired height in order to keep the package within the launch zone. The cushion test, making sure the material enclosed in the egg will not damage the egg when it is launched. Delivering solutions, bridging distances.